Hi everyone, I'm Paul Duvall. I'm the CTO at Stelligent, and I'm pleased to welcome everyone to today's Getting Started with AWS Code Services webinar. This webinar is a collaboration between AWS and Stelligent. In today's webinar, we'll be talking about and demonstrating AWS's new developer tools for continuous delivery and deployment. So namely AWS CodeDeploy and CoPipeline. So we'll show you how both of these services can work together to build a fully managed continuous delivery pipeline for your application. So I thought I'd give a little bit of background on Stelligent. So we're a technology services company that provides continuous delivery solutions in Amazon Web Services. So we aim for one-click deployment. So we have a singular focus to help enterprise customers continuously deploy their software when they want to and with confidence. So we've been providing continuous integration, continuous delivery solutions in AWS since 2009, focused exclusively on AWS for the past 3 years. So typical Stelligent engagement includes automating the infrastructure and implementing deployment pipelines that underpin our customers' applications. A typical Stelligent engineer is experienced and skilled in software development and systems operations, is a certified AWS associate or professional, and readily joins in our customers' teams. So we're firm believers in the DevOps culture, and our engineers collaborate directly as team members, so we participate in stand-ups and sprint planning and retrospectives. And we treat all work products as part of the same asset base. And that is that it's tested, it's versioned, it's documented, and we'll go over that later on. So we were a participant in the CodePipeline, CodeDeploy, and CodeCommit beta programs. So I want to give a brief introduction to today's speakers. Rob Brigham leads the product management team for AWS Developer Tools, which recently launched the 3 new AWS Code Services. He's been working in the developer tools industry for almost 20 years and has spent the last 3 at AWS. Johnny Sivilak is a DevOps automation engineer for Stelligent, and he specializes in building continuous delivery pipelines in Amazon Web Services. And he's been with Stelligent for over 3 years, working on retail, financial, and government customers. He is an AWS Certified Solutions Architect and an AWS Certified Developer Associate. So onto the housekeeping. So we're going to be recording today's webinar, and we'll send an email out with a link by tomorrow. If you have any questions throughout the process, throughout this session, just go to webinar. There's a questions panel. We'll do our best to address any questions throughout the presentation, and then also after the demo that Johnny gives. So with that, we'll turn it over to Rob Brigham from AWS, and he's going to start discussing the AWS Code Services tools. Rob?
Thanks, Paul. I just wanted to take about 20 minutes to give everyone a quick introduction to our new set of AWS Code Services. These services really have an interesting backstory. On the surface, they might look like new products that we built from scratch recently, but actually these are born from a set of tools that we've been using internally at Amazon for over a decade now. And the reason that we're now making these tools available publicly and talking more about how we do internal software development and delivery at Amazon, the reason is because our customers are asking for it. A few years ago, we noticed a distinct trend in the conversations we were having with our customers. In addition to asking us how to use our new services and what new features we're adding to those services, they'd also ask us some very detailed and probing questions about how we were building those. They'd want to know things like what types of engineers we were hiring, what team structure we use, what processes we use, tools we're using. So being good product managers who are curious, we'd ask them why they wanted to know that. And what they said is that they wanted to learn how it was we were able to launch these new services and deliver new features to them so quickly. So after hearing this from customer after customer after customer, we knew that there was a strong demand for that information and a big opportunity for us. And it was really that motivated us not only to make these tools available to customers, but also to talk more openly about how we do DevOps internally at Amazon. So before I go any further, I have to address one elephant in the room, and that is that I had a very strong dislike for that term DevOps. And I think the reason why that term bugged me the most is because it was very fuzzy. So a lot of different people use DevOps. When they say it, they'll talk about a lot of different things. So when someone says that, it's kind of difficult for other people to know what they're talking about. So really, since I'm using this term here, I'm going to have to define it so everyone knows what I'm talking about. And I'm not going to define it directly, but I'm going to relate it to something that we are all very familiar with, and that is the software development lifecycle. So here is a typical development lifecycle for a web app or a web service. You're going to have your developers on one side, customers on the other. And every new feature that's built for a product is going to have to go through this loop. The developers are going to come up with an idea, they're going to implement it, and then that code's going to have to be built, tested, and go through a release process where it's finally deployed and gets into the hands of customers. And once customers can start using it, then that development team can learn about it. They can look at the customer usage data, they can get feedback directly from customers, and once they get that information and feedback, they can use that to determine what they want to do next. So they might iterate and refine that feature they just built, or they might build a completely new feature. So there's a couple important things to note about this development lifecycle loop. The first is that the speed it takes to complete this will determine your business agility. It's going to determine how quickly you're able to respond to customer asks and customer requests. At Amazon, we focus intently on making sure we can move through this loop as quickly as possible. The other thing to note about this is that your developers are only adding value here in the eyes of customers. They're only adding value when they're writing new feature code. So any time that your developers spend either building a delivery pipeline or hand-holding changes manually through that delivery process, all that time is lost in the eyes of your customers. Customers are only going to be able to see the new features that they're building. So what you want to do is make sure that they're spending their time on that left-hand side of this life cycle writing new code. And to me, it's really those two key points that make up the heart of DevOps. So to me, DevOps is any efficiency that you can insert into this process that speeds up that learning life cycle and allows you to move quicker. So to make this more concrete, I'm going to talk about Amazon's own transformation of DevOps. So like most companies, we did not start off optimized in a DevOps manner. If we go back to 2001, the Amazon.com retail website was essentially a large architectural monolith. Now don't get me wrong, it was architected with multiple tiers, and those tiers had multiple components in it, but they're all very tightly coupled together where it behaved like one big monolithic code base. So to visualize what that was like on our development teams or development delivery process, I've re-rendered this software delivery process to represent what it looks like with a monolithic application. So in this environment, you're going to have many, many, many developers that are all working on this singular application. And even though you have, like each individual developer is only going to be working on a small piece of that application, they're still going to have to take on all of the overhead of coordinating with everyone else on that project. So if they're making a code change, adding a feature, fixing a bug, they're still going to have to make sure that change is not going to break something, break compatibility with some other code in the system that depends on it. If a developer wants to add a new feature that requires an upgraded shared library, they're going to need to convince everyone else on that project to upgrade to the new shared library at the same time. And then even if they're making a very quick fix and want to push that out into production, they can't do that just on their own. They have to coordinate with everyone else and merge all the changes together into one massive release, which then gets pushed out to customers. So with this process like this, it adds a lot of overhead, adds a lot of coordination, and it really slows down this learning life cycle. So for a company like Amazon that kind of prides itself on efficiency and speed, this was really weighing on that process. It was affecting our business agility, and it was also frustrating all the engineers involved. So that really motivated us to make some big changes. And there's a couple big ones that we made. The first was architectural. So we took that big monolithic application and we pulled it apart into a large number of these small single-purpose services. So we'd have a service that sole job was to calculate the tax correctly. We'd have another service whose job it was to render the buy button correctly on the different product detail pages. And we went through that code base and basically pulled everything apart into these independent units, wrapped each one of those in a web service interface, and then we only allowed those to communicate to each other through web service APIs. So to give you an idea of the scope of this architecture, I've included this graphic here, and what this represents is all of those services that comprise the Amazon.com retail website around 2009. So today it's a much larger number than what you see here. Now, we didn't have this term back then, but today you would call this a microservices architecture. So in addition to this architectural change, we also made an organizational shift. Before, we had this large hierarchical engineering organization, and we pulled that apart as well. And we broke it down into these small, what we call two-pizza teams. And each of these teams were roughly around 8 people. So depending on how hungry your developers are, you might need a little more than 2 pizzas to feed them. But essentially, there's very small teams that took on full ownership of one or maybe a few of these microservices. And when I say full ownership, I mean everything. These teams work directly with their customers, whether they be internal or external. They set the product roadmaps, determine what features they were building. They designed those. They developed those. They wrote the tests for those. They deployed them into production. And they also operated those microservices in production as well. So with that full ownership also came full accountability. If anything went wrong anywhere in that process, they were the ones that were responsible for fixing it. So if they skimped on their test coverage and accidentally were pushing bad changes into production that broke in the middle of the night, it was that same team that was receiving those pages and had to wake up to fix it. So what this did is that it fully aligned the incentives so that one central engineering team was motivated to make sure that the entire end-to-end process operated very efficiently. So again, we didn't have this term back then, but today we would call this a DevOps organization, where we took all that responsibility of development, test, and operations and laid it all onto a single team. So after we made these 2 changes, it dramatically improved that front end of the software development process. We had these very small 2-pizza teams that were able to quickly make decisions, quickly add new features or make changes to their small microservices. That was working great, but when they went to deploy these services to their customers, we found out we had a tools gap. So in the past, we relied on a large central engineering team whose sole job it was is to take these large batches of changes and push those into production on a very infrequent basis. That team was just not set up to serve thousands of different microservices all deploying on their own schedule. So we had to solve this by building a new set of tools. So we did that, and these tools had some very unique characteristics. The first is that they had to be self-service. Since we had thousands of these small 2-pizza teams, there was no way a tools group would be able to serve all of those at once or onboard them all at once if it involved hand-holding to ramp them up. So what the central tools group did is that they created a set of tools where all of these teams could come to a web portal. They could learn about these services that are available. They could learn how to use them. And then they could just automatically provision whatever resources they needed to start using these tools. So you can say it was very AWS-like, except this occurred before we even had AWS. Second is that all these tools had to be technology agnostic. When we broke that organizational structure down to these 2-pizza teams and we fully empowered those teams to operate independently and make their own decisions, they all took advantage of that. And they, depending on their service and depending on the people they had on their team, they would choose different operating systems to use for those services, different programming languages, different application frameworks. So there's massive diversity of technology that these tools were going to have to work with. Third, even though we broke apart that central engineering org into these independent teams, we still wanted teams to learn from each other. And the most scalable way we found of doing that is to be able to take these best practices that are learned by one team and bake them into our tools so that all the other teams can take advantage of those as well. And lastly, you can say we drunk the microservices Kool-Aid, where we didn't want to build this complete end-to-end tool chain that was all one big monolith and all tied together. We wanted to build these pieces of that tool chain independently and basically allow these teams to pick and choose which ones they wanted and wire them together in a way that worked best for them. So I want to talk about a couple of these services that we built internally. The first one is Apollo, which is our deployment service, and its job is essentially to get bits onto a box. We've been using Apollo to deploy the Amazon.com retail website for over a decade now, and we also use it to deploy our AWS web services. And over that time, we've learned a lot about how to do deployments well. We've learned about how to deploy to application environments without requiring any downtime. So we've taken that rolling update capability and baked that into the service. We've also learned how to catch mistakes that make their way into production and deployment. So if a bad change is rolled out and it starts to affect the health of that fleet, we have health tracking built in where it'll catch that early and stop the deployment. And then once that happens, we make it very easy for developers to roll back to a known good version of that application. Another service that we built after we had automated deployments is a continuous delivery engine that we called pipelines. And this really came about after we became frustrated with, even after we had an automated deployment engine, it was still taking a long time for code changes to make their way from source control, or from when a developer checks it into source control, to make it through that entire delivery process to being in the hands of customers. It was taking roughly on the order of weeks for that to happen, and we wanted to move quicker than that. So when we dove into that data to see where that time was spent in the whole process, it wasn't so much the duration of any action in the process, so it wasn't the duration of a build or of a test run or a deployment. It was really all of this dead time in between where manual handoffs were happening. So after one step was completed, someone would cut a ticket or send an email to another person to do the next step, and it would essentially sit there a while until someone noticed it. Someone would pull it off that queue. They'd usually stick it into another holding bin to batch together with other changes. And they'd have to manually kick off a job, wait for that job to complete and be noticed, and then pull that off to actually, get the results and hand it off to the next person. So it's really all the manual handoffs that were adding up to this weeks of time. So what we did is we created a continuous delivery workflow engine that allowed these teams to completely model out how code should go from source control into the build and unit test stage, how that should move into some other pre-production environments where it's deployed to a test environment and other off-box tests are run against that, how you want that to proceed to other staging environments, and ultimately how you want it deployed into production. And after the teams wired all of these steps together in the process, pipelines would automatically move every code change through that consistent set of quality checks, and as long as all of those passed successfully, it would continue on through that deployment process until it eventually reached production. So this has been incredibly successful internally and used by a vast majority of teams. And for the teams who are deploying these small microservices on a fully automated pipeline, they're able to reduce their time from initial check-in into production down to the order of minutes. So yeah, it's really after adding these missing tools that we've reached this state of DevOps Nirvana, where we have these fully independent small two-pizza teams that are working on these small microservices that can now all deploy independently on their own cycle to release their changes to customers. And when our customers ask us, how is it that Amazon's able to move so quickly, this picture here really depicts it, the answer in my mind. Even though we're a large organization with many large businesses, internally, we operate like a large number of these very small independent startup teams that are all able to move as quickly as they can in a decoupled manner. So this really is kind of the secret of how Amazon's moving quickly. So there's a number of ways that you can measure success here. One of the ways that we've shared publicly are the number of deployments that we do. So when you take thousands of these small two-pizza teams that are working on these small microservice architectures, doing continuous delivery of those services across many dev, test, and production environments, that all adds up to an incredible number of deployments. So if we look in 2014, during a 12-month period, Amazon did over 50 million deployments in that time frame. That averages out to over 1.5 deployments every second during the year. So it just gives you an idea of the scale of how quickly we're turning that crank across all of these different teams. So when we tell customers a story, it inevitably leads to the question of how they can do the same. And I'll be honest, it's a very complex answer. There's so many different aspects to it when you talk about organizational change, culture change, process change. There's a lot of different angles you need to look at there to become fully optimized. But one key enabler of this, one thing that you absolutely need, is this continuous delivery pipeline that's very efficient and reliable. And when you're setting up one of these continuous delivery pipelines, there's two main pieces that you need to tackle here. The first is that you absolutely need to fully automate your software deployments. And this is because you're going to be doing it a lot. So any single change that you make or released into the hands of customers, you're going to need to deploy many times to your development environment to make sure that you have the feature built successfully. You're going to need to deploy it probably multiple times to test environments to make sure everything's running properly and there's no regressions. You're going to need to deploy it into any kind of pre-production or staging environments to make sure it works in that type of setup. And then you're going to need to deploy it to production. So every small change that you release is going to need to be deployed many times to many different environments. And if there's any manual step involved there, it's going to add friction. It's also going to add complexity and the opportunity for error there. So after you get your application deployments automated, the next thing that you want to do is tie together that end-to-end release process. So that's really automating all those transitions in between that initial source code change to how that gets built and unit tested, to how it goes to your test environments and gets additional validation, how that moves into your staging environments and whatever production environments you have. You want to wire that together and make that as automated as possible. So not all customers, actually there's a lot of customers who are going to have maybe one or some manual steps in here. And even inside of Amazon, there are teams with manual steps in this process. But the ultimate goal here is to make this as automated as possible because, again, it's going to help you turn that crank faster. So there are two services that directly address each of these core needs. We have CodeDeploy for doing automated deployments and CodePipeline for automating that end-to-end release process. And I'll be upfront with you that creating these automated delivery pipelines takes a good amount of work. It is an upfront investment, but that investment you make is going to more than pay off as you increase your business agility. And as you're responding quicker to customers and you're releasing more of these small changes more quickly, you're going to be paying that off again and again and again as you increase the speed of your business. So with that, this is really kind of why we're thrilled to have great partners like Stelligent who can help customers through setting up their first continuous delivery pipeline and really show them how to do that using their great experience. So with that, I'd like to turn things over to Johnny, and he's going to give us a better hands-on demo of what it's like to use these services and set up a continuous delivery pipeline.
Right on. Thanks, Rob. All right. So, like everyone said, I'm a DevOps automation engineer for Stelligent. My name is Johnny Sidolek, and today I'm going to be demoing drive mouse control. There we go. I'm going to be demoing CodeDeploy and CodePipeline in the context of an application that we've developed internally just to do demos with. So the things we're going to be talking about today, we're going to talk a lot about CodePipeline. We're going to talk a lot about CodeDeploy. If you don't have any experience with those, that's perfect because we're going to be starting from the ground and building up with those two things. We'll also be talking about Jenkins a good bit. If you haven't used Jenkins in the past, it's a continuous integration server. It is used pretty widely. It is free, it's open source, and there is a plugin for CodePipeline that integrate with the service. So we'll be talking about that a good bit. If you haven't used Jenkins in the past, that's okay. Everything we're going to talk about, I'll give enough background, so hopefully it makes sense. If not, just pop a question up and we'll try to answer it on the fly. This application is hosted in GitHub, so that's where the source is. It's actually open source, so you can see it later, but we'll be talking a little bit about GitHub. And then we'll be talking about Dromedary, which is the name of the application. It's a simple pie chart app that I'll be showing off. So if you had experience with that already, I'd be really surprised because we really just started putting together in the past month. So let's get started. So we're talking a lot about CodePipeline. So give a little bit of background into this. CodePipeline is a orchestration engine for your continuous delivery pipeline. It allows you to break up your deployment process, your build and deployment process, into separate stages and actions that comprise the different activities of your pipeline. CodePipeline has different types of pre-built actions, source, build, test, deploy, and you can actually leverage custom actions as well, give you some more flexibility. We'll talk a lot about the building actions as we go along. CoPipeline's focus is on orchestration, not implementation, so you do need something backing it up. In this case, we'll be using Jenkins. The Jenkins plugin also supports CloudBees as well. If you're using that, you're already good to go. Either of those running. There are custom actions as well you could use. Yeah, so that's CodePipeline. CodeDeploy, whereas CodePipeline makes leveraging or orchestrating your pipeline a snap, CodeDeploy makes deploying your application a breeze. It really makes it so easy. You'd really be okay letting the summer intern do it if you didn't just lose your summer intern in the past 2 weeks. CodeDeploy works by installing an agent on your servers. Those can be either EC2 or on-premise. Those agents are discoverable by the CodeDeploy service, and it will issue commands to that agent who will then do things on that server to deploy your application to it. And we'll talk a lot about how that works. And Rob was just talking a lot about continuous delivery pipelines, and CodePipeline and CodeDeploy both work exceedingly well for implementing these things. This is actually a 6-part heuristic that Stelligent uses, and that works really well with CodePipeline. So we keep all our documentation, all our automated tests, all our code is stored in our source control repo and versioned. And then CodeDeploy and CodePipeline continuously monitors that repo and issues commands to build and test that, as well as issues commands to CodeDeploy to deploy to our servers. And then CodePipeline provides a nice, pretty view of the entire pipeline so you can keep an eye on what's going on. And I literally can talk about this stuff all day. People avoid me at conferences because of this, because Chuck figure out about this stuff. It's actually much more interesting if I do a demo. So I'm going to skip into that stuff because I'm actually not a big fan of slides anyway. So let's talk about those different things we're doing. So this is Dromedary. It's a super simple pie chart app. It doesn't do anything that exciting, but it is complicated enough and has enough moving parts that it is interesting to see go through a continuous delivery pipeline. For today's demo purposes, I'll be adding a new color to the pie chart. My boss's favorite color is orange, so I'm going to add that, hopefully get you some browsing points. So we're actually going to write code live and hope nothing goes wrong during this demo, so let's do that. Pull up Sublime Text. I may have cheated and written this code earlier, so I'm going to uncomment it. And there it is. We're going to add that to our repository, push it, and that worked. And if we go over to our GitHub page, just got added. So that's all we're going to do with GitHub. So if you look now, you'll see our code pipeline for Dromedary. There are a number of different stages here, each consisting of different actions. So a stage is really just a logical grouping of actions, and whatever logical grouping makes for your application, you'll have to figure out for yourself. But there are certain patterns you're going to tend to follow, and this is one of them. The actions themselves aren't actually code pipeline doing anything. CodePipeline defers its actions to a number of providers, and there are built-in providers, there's hooks into other services, and there's the option to create custom actions for whatever you need if you need that kind of flexibility. There are 4 types of baked-in actions. As you can see, we have all 4 on here. It would be kind of hard to see what they're doing. So source actions, those are the type of actions that monitor your source control repo to see if a change has been pushed. As of right now, CodePipeline only supports GitHub and S3 as source actions. So if you have your source hosted in GitHub, you're good to go. Alternatively, you can put it in an archive and push it to S3, and then CoPipeline will pick it up from there. The build and text actions, which are just getting kicked off now, allow you to run any type of build or test jobs you need to do. For the purposes of this demo, we're deferring all of these actions to Jenkins, and I'll talk about how the integration works. But there are custom support. There's support for custom actions, but there's also hooks into third-party tools for a lot of the testing actions. Runscape and BlazeMeter, two of them running off the top of my head. But if you're doing some just simple unit testing stuff, deferring to Jenkins is a totally okay way to do things. And since that's all we're doing here, that's all I'm going to talk about. There are also deployment actions, which I'll get to in a little bit. But as you can see right now, my build just failed. So we're going to dig into here and kind of figure out why it failed. So to do that, we'll go over to Jenkins. So if you guys haven't seen Jenkins before, this is what it looks like. It's a continuous delivery server. You define jobs, and in the context of CodePipeline, those jobs are linked to CodePipeline. I'm going to talk about how that works. But to see when a job fails, you just drill in, and you look at the console output of that job. And if we scroll down, we'll see that I broke the unit tests for this job, so it stopped the pipeline. None of these changes are going to be propagated any further through. So I don't have to worry about these changes being pushed to production. I'm not sure they're right. So it looks like the test that failed is looking for a count of 3 colors, and I have 4 now. I probably should have been a good developer and run these tests locally before I committed, but that's a much less exciting demo when everything goes right. So I'm going to fix those tests right now. And I'm going to make sure they're there and commit them. I'm going to push them to GitHub, and they're going to kick off another run of the pipeline. So since watching that go through again is probably kind of boring, let's actually look at how the Jenkins integration works with CodePipeline, because there are some things you have to change, or not change, but do differently when using building a job for CodePipeline versus building any other job. One thing you'll probably be used to setting up, if you're used to setting up Jenkins jobs, is the source control management section. Probably for most of your jobs, you're referring to a Git repo or a Subversion repository where Jenkins will pull that, and if it detects a change, it'll pull it down and then kick off a build. It works very similarly, but instead of going against your version repository, you're actually going against CodePipeline itself. Actually, the hardest part about talking about CodeDeploy and CodePipeline is that you get them mixed up all the time. So I'm sorry if that happens over and over again. But so with the CodePipeline Jenkins plugin, you'll have to specify a Jenkins CodePipeline source control repo. In air quotes, it's not really source control, but you link it back to the job, and there is some configuration you have to do on the CodePipeline then to handle that job, to know what job to talk to. But it will pull against CodePipeline if it detects a change in that job, as in a change has come through that it should process. It will securely pull down the artifact that it needs from CodePipeline, explode it into the workspace, and then you can run whatever build steps you want to run. For this, we're a pretty simple Node app. We're just going to run our unit tests. However, after that's done, there's one more thing we need to do, and that's set up the publisher for CodePipeline. So whereas each CodePipeline action requires an input artifact, they may optionally provide an output artifact as well. So this is going to be any folder inside your workspace. In this specific case, we're leaving the location blank, and it's defaulting to zipping up the entire workspace. If you have a specific folder that you want to move on to future actions, you'd specify it here. But one thing you cannot do is specify a specific file. What a CodePipeline plugin is going to do is try to zip up whatever you hand it. If you hand it a file, it's going to get confused and mess up further down the line. So if you're doing stuff where it's setting up a jar or something, that can get tricky. So after you set up those two, you can save it, and they will show up in your, I'm going to show you exactly what it looks like when you're setting it up. So we're setting the project name in Jenkins so it knows where to find it. We're saying what the source input artifact is and the output artifact are, and those are kind of linked to the names of the jobs themselves. So that's what it looks like from that's what the configuration looks like from the CodePipeline end, and we talked about what it looks like from the Jenkins end. The beta stage. Yep. So right now it's running beta. You can tell that because of the blue bar next to it means it's in progress. For dromedary, we're deferring our deployment to CodeDeploy. There's two built-in hooks for deployment that you can do within CodePipeline. One is CodeDeploy, the other is Elastic Beanstalk. We won't be talking much about Elastic Beanstalk today, but it's another offering from Amazon you might want to check out if you're looking to do automated deployments. So I'm going to switch over to CodeDeploy real quick since it's already getting ahead of me. So this is CodeDeploy. And as we talked about earlier, CodeDeploy handles deploying applications to your running instances. CodeDeploy does have a couple of moving parts that I want to just like set the vocabulary for before we go on, just so what I say makes sense, or at least has a better chance of making sense. So the main object you're going to work with in CodeDeploy is an application. This is CodeDeploy's representation of your application within CodeDeploy. It's going to link and coordinate all the application revisions, deployment groups, deployment configurations that are used. And I should probably define all those terms too. A deployment group is the group of servers that you want to deploy to. Those can be EC2 instances, but they don't have to be. You could set up on-premise instances with CodeDeploy, although there is an associated cost with that. But anyway, any way you do decide to set this up, you're going to define a group of servers that CodeDeploy will identify and then push that deployment to. So these could be your production application servers, they could be your QA dashboard servers, whatever group of servers makes sense to deploy to at once. CodeDeploy has a concept of deployment configurations. It comes with 3 built-in ones, but it's just a way to define to CodeDeploy how you want your deployment to be run and what constitutes a successful deployment. So depending on your application, you may need to roll out to all your servers, and you want to do it one at a time so nothing goes down. And a successful deployment consists of all the servers being happily deployed to. Maybe your application doesn't require that level of success. So you can just throw out your new application to all your servers, and as long as one of them works, you're happy. And you might be okay with that if it's like a development environment that you're kind of beating up, but that's less okay when you're deploying your e-commerce site to your production servers. So there are 3 built-in types. You can define your own if you so need to. And then there's active deployments, which is the actual action of deploying revision of your application to the deployment group representing the servers you want to deploy to. So I was hoping to catch this in action, but I've been talking far too much. But we can still go over look at it in the history. So this is us deploying to our dromedary servers. CodeDeploy has a series of lifecycle steps that are listed right here that I'm going to go over real quick, and I'm going to talk about them a lot more. But these happen during every deployment, and those are application stop, download bundle, before install, after install, application start, and validate service. They're all very self-explanatory to what they do. There are 7 in total, 2 of which, however, you do not have much access into controlling what they do. Unfortunately, or fortunately, they are what CodeDeploy kind of does on its own and figures out. If you have some slight input into it, you that configuration in through a file called abstract.yaml, which I'm going to talk about in a minute. The other 5 lifecycle events, application stop, before install, after install, application start, and validate service, you can actually directly hook into and have it run whatever excuse me, have it run whatever logic you require for your application deployment to work. Those hooks are also defined in the abstract.yaml. So let's just look at dromedary's abstract.yaml. So dromedary has a very simple abstract.yaml because it's a very simple application. You can get much more complicated than this. I think this is a good way to talk about the 2 major sections that you'll probably be messing around with a lot when you're doing code deploy work. The first section is the file section for dromedary. We're just dumping the entire application bundle into /dromedary, which is where we're serving the application out of on the application server. So we're just saying grab everything from the application bundle, drop it into that folder. If you're in a situation where you need more nuanced deployments, you can specify certain files going to certain directories. You can actually name those files specifically or use wildcards to move bunches of files at once. You can also set the owner of those files and the permissions of those files as you lay them down if they need to be different for your application. The second major part of the abstract file is going to be this hook section. And this is where you can hook into the 5 other lifecycle events directly and run whatever code you need to run. So we're not doing anything for before install, but that's what it would look like if we were. Just comment it out. We are doing stuff for the 4 other lifecycle events. They're all pretty simple. So I'm just going to show you one of them, which is the validate service one. I think validate service is probably the most powerful hook. Rob was talking a bit about how identifying failed deployments quickly is so important, and validate service is really an excellent way to do that. So I'll show you the validate service hook or script for dromedary, and it's very simple. All it does is try to pull down the main page of dromedary, make sure it's working. What's nice about this is if it's not working, you don't have to wait till the deployment's complete. You don't have to call on your application testing team. You don't have to run a suite of automated tests after the deployment. As this is a very simple smoke test to make sure that things are working correctly and things have worked out all right. And if they didn't, you know midway through deployment exactly when the problem occurred. So you don't have to spend another 10 minutes after deployment trying to figure out which server isn't working and what the error is and what went wrong. You know exactly what happened at exactly the right time. I like CodeDeploy for a lot of reasons, but the validate service hook is probably my absolute favorite reason. Anyway, so I've been talking about CoPipeline for a while, so we're probably way past that point in CoPipeline. I'm trying to get them right. So if you look at this, we'll show about how it looks like when you hook into CoPipeline into CodeDeploy. So you have to specify your deployment provider, the application name, which is dromedary, deployment group, which you're using, and then the input artifacts that you want to use, which is the output of this build step above. And then finally, we're going to run our suite of acceptance tests against that deploy that we just did to our test server. So those ran in Jenkins, and it looks like they ran successfully. You can go over there and check. Output from here. And I did cheat a little bit and fix the acceptance tests at the same time fixing unit tests. So this is finding the 4 items we needed. So this is all good. So if we were to go to dromedary now and refresh, we'll see we now have orange showed up. So without any real input from me besides me pushing the file into GitHub, the unit test ran, verified everything looked right. When they didn't, it threw an error. When we fixed that, kicked off another pipeline instance, ran all the way through, successfully deployed the latest version to our test server and then ran our acceptance test against it. So we went over a lot here. So let me switch back to PowerPoint because I think I have a, yeah. So Rob talked a lot about how important these continuous delivery pipelines are to building out the built-in quality into your application lifecycle. It allows you to change it out faster and with higher confidence that they're going to work. And then we talked about how CodePipeline is a really excellent way to orchestrate that. You get it for free, basically. There is some cost associated with CodePipeline, but those costs are minuscule compared to what you'd spend setting up even your own like fancy Jenkins server to handle all that pipeline logic, much less another third-party tool to figure out all that. And then CodeDeploy works hand in hand with CodePipeline to quickly roll out updates to your servers in a scripted, repeatable way, and in a way that if something does go wrong, you're notified immediately and can respond quickly. And that's it for me. So I'm going to hand it back over to Paul, and he can talk some more.
Thanks a lot, Johnny. Appreciate it. So we have about 10 minutes left, and we have a lot of questions. So I thought I'd go through a few of those questions. But before we do that, I'm going to send out a poll just to get your feedback on today's session. And then in the meantime, we'll start looking through some of the questions and then having Rob or Johnny answer them. So I will leave that open for about the next 15 seconds. Okay, thanks a lot, everyone. So in the time remaining, I'll start going through some of the questions that people had. First one is, can CodePipeline be used for PHP HTML websites and pushing them to dev, staging, production? Rob?
Sure. Yes, it can be used for, I haven't seen something it can't be used for yet. Basically, how we built CodeDeploy and CodePipeline is to be very technology agnostic. So there's kind of like these building block services that you can kind of plug in with anything. And CodePipeline in particular is meant to be very extensible, so it'll work with many different types of tools. But yes, as it relates to like what kind of application framework you're using, that's probably going to be more related to your deployment engine and whatever build service you're using. So there are many that you could use for these different application types or even static HTML sites, and you can absolutely use it with both CodeDeploy and CodePipeline.
Okay, thanks. And Johnny, does CodePipeline pull code from CodeDeploy, or is it coming from GitHub?
So CodePipeline can pull code from two locations. One is GitHub, which is where I was pulling from in the demo. If you're not using GitHub, you can archive or zip up whatever type of repository you want to use. Zip it up and then push it into S3. And then CodePipeline can alternatively monitor an S3 location. And if it notices a change there, it'll trigger a build as well. So for us, we're using GitHub. It then will continue down the pipeline, and then once it needs to do a deployment, it will deploy the code. It will push the code into CodeDeploy, and CodeDeploy will push it to your servers.
Okay. All right. Thanks. Somewhat related to that, Jose had a question about whether CodePipeline when will CodePipeline support AWS Code Commit and GitHub Enterprise? I thought Rob, you might be able to answer that one.
Sure. Yeah, I see a lot of questions around like source control integration, whether it be like CodePipeline or CodeDeploy, and when it would work with like Bitbucket or Code Commit or GitLab. So there's a whole host of those. I think the answer for both of those is the next step that we're going to take with CodeDeploy and CodePipeline is to basically build in source support so it could work with any Git source control system. So you could plug it in with anything that you could point to an endpoint and supply some credentials like an SSH key to, and it would connect it to those and use those as source as well. So that would be a broad solution across all of these Git-based source control systems. So that's something on a roadmap. It's high up on the list, so I don't have a date, but I can say that is a high priority for us.
Okay. All right, thank you. And then, Johnny, there's a question from Adam about the value that CodePipeline has. There was some related questions to this from some other people, but the value that CodePipeline has over just, say, running a Jenkins server. And then related to that, there was a question whether or not you have to have some provider other than CodePipeline to do the build actions that you went through.
So yeah, there's a lot there. Yes, you do need some sort of build provider in the backend. CodeDeploy doesn't have any sort of compute capacity associated with it. So if you want to execute anything that's not a built-in action it already knows about, you're going to need somewhere that it can run that. The Jenkins plugin is really nice for doing that because you can set it up pretty easily. And Jenkins is a pretty well-known and highly used application. So if you have a problem with it, you can usually Google it and find a pretty quick answer. As for whether or not it's worth it to use CodePipeline if you already have Jenkins set up, I mean, it really depends on what your pipeline looks like. I've seen pipelines that have a lot of moving parts and lots of conditions you want to run in parallel, things you want to stop, where you want to insert a manual break. With doing that with Jenkins is possible, yes. The time you spend setting it all up and the hair you lose while doing it, because it's really frustrating to do, probably not worth it. CodePipeline does let you set up all that pretty easily. I didn't really talk about these things today, but you can insert manual stops. You can actually really easily parallelize different jobs run at the same time. These things are possible with Jenkins, but harder and very difficult to visualize. You need to get a whole mishmash of Jenkins plugins in place to do it. So CodePipeline does a really good job at orchestration and visualization, and that's all it does. It focuses on one job and does it well. Jenkins' core strength is repeatably running jobs based on a variety of triggers. By using them together, you are getting a good amount of value add. And as CodePipeline's features do increase and there's more hooks into other things, I think you're going to see a whole lot more bang for your buck than trying to do everything with Jenkins by yourself.
Okay, thanks. And yeah, there was a related question from Adam about how to incorporate, or it was John, sorry, it was how to incorporate formal approval process. And so I think you answered that question in the sense that you can incorporate manual steps into the workflow if you have to have a sign-off by a human at some point in the process.
Yeah, so one stage we talk about a lot is the exploratory stage of a continuous server pipeline, which is kind of the manual spot checking. And some applications do require some sort of manual processes. I know IFOA compliance testing for making sure that things look right to people with disabilities requires some manual testing. So stuff like that, you can definitely put a manual stop in there and then do your whatever manual steps you need to do and then kick off the pipeline from that point again manually. Okay.
Rob, you had something to say?
Sure. So like I said, CodePipeline was derived from our internal pipelines tool. And in our internal pipelines tools, we actually have a formal mechanism in there for doing manual approvals. And it's something that we definitely have on our radar and a roadmap list for CodePipeline. CodePipeline, since it is extensible, you can plug in your own types of actions in there, so you can work some other approval processes into the tool today. It's just going to require a little more work, but I would say having a formal, built-in first-class manual approval step is something that is definitely on a roadmap for CodePipeline.
Okay. And there are a number of questions around how, say, CodeDeploy compares to OpsWorks. Johnny, I don't know if you want to answer that question. And maybe how it compares to some of the other ways that you can deploy within AWS.
Sure, I can talk a bit about that. So on the spectrum of managed services, as far as all the offerings Amazon has available, housekeeping stocks on the one end of everything's very much on Rails, and you can set it. You just put in your input and figure out everything for you. On the other end is CloudFormation, where you have to kind of do everything yourself. In the middle are CodeDeploy and OpsWorks. CodeDeploy leans more towards the do-it-yourself end. OpsWorks leans more towards the kind of manage for you already end. So with OpsWorks, it also has a similar lifecycle concept, though it's a little bit different. But OpsWorks will actually do a lot more different things for you. It'll take care of spinning up your instances. You can attach load balancers in there. And then everything with OpsWorks is driven by Chef Cookbook. So anything you want to do on that instance is then driven by Chef Cookbook. If you're already doing a lot of Chef, it might be a really good option to look into. CodeDeploy doesn't do a lot of those things. It's just very appspec.yaml. And then you might want to write some bash scripts to move your files around. If you still want to use Chef, you can, but you'll need to script out how you want to call into it and figure all that stuff out yourself. So CodeDeploy gives you a lot more control and flexibility with a cost that there's a lot more DIY stuff you have to do. Whereas OpsWorks does a lot more things for you and has a lot more control over what's going on. But if you do need a little more flexibility, it's more difficult to plug it in there.
Good. All right. Well, we're at the top of the hour. Thanks a lot, Johnny. Thanks a lot, Rob. Thanks a lot, everyone, for attending. And just to note, we're going to have recording available. We'll have links that were referenced, including the open source dromedary that Johnny went over. And we'll also do our best to answer any questions we weren't able to answer during this time frame. So thanks again, and hope you have a good rest of your day.